Greetings everyone. We at SEDSKCT are very happy for presenting COSMORENA 20. Thank you all for your participation. Today is the second talk of the series Astronomy, Astrophotography and Post-Processing. A small information regarding certificates. At the end of each talk, feedback forms will be circulated. There are totally 4 talks in astronomy, astrophotography and post-processing. Certificates will be provided only for those who attend all the talks of the series. Please use register mail ID in all feedback forms to avoid problems regarding receiving certificates. I again welcome you all to COSMORENA 2020. Today's talk will be on the colorful cosmos processing astronomical images. Now I would like to welcome our honorable guest speaker, Mr. Keerthi Kiran, a hobby astronomer who walked into the allure of this infinity, drawn by that twinkling blanket of stars, is what Mr. Keerthi Kiran describes himself as. After being drawn into the world of astronomy, Mr. Keerthi Kiran started to travel in the pursuit of dark skies. He is currently the secretary of Bangalore Astronomical Society, wherein he educates young students and the public through exciting workshops and awareness sessions. It's been an honor for us in welcoming you, sir, and I request our speaker, Mr. Keerthi Kiran, to share his experience and knowledge on the colorful cosmos processing astronomical images. Thank you.
Hello. Thanks for that wonderful welcome. So, as Deepika already explained, I am a member of Bangalore Astronomical Society. It's an astronomy club from Bangalore, and we are very active. We have a very active Google group, Facebook page, and also Telegram group. And we have more than 400 members in the Telegram group, and we do a lot of discussions about astronomy. So I have been doing astrophotography from the last 10 years or so, and I have been to the US for capturing the solar eclipse. I have been to Ladakh and many places in the Himalayas to take photos of the night sky. But also in and around Bangalore, whenever there is a clear sky, I keep going out to take photos of the night sky. So today we will see how to process the astronomical images, and with a few examples. So I don't have a presentation as such to present, but I'll take a few good examples and I will show you practically how to do astronomical image processing. Okay. So is everybody able to hear me well? And also let me just share my screen and let me know if you can see my screen. So maybe one of the organizers can confirm that they can hear me well and as well as see my screen. Please.
Yes, sir, you're audible and your screen is visible.
Great, thank you. So one thing that you could do is probably pin my desktop screen so that everybody, whoever logs in later, they will start seeing my screen. Okay, all right. So why do we? So what is astrophotography? First of all, so astrophotography is the photography of the night sky. So you might have seen several photographs, several astrophotographs. So, for example, this is the comet Neowise, called as an astrophotograph. Similarly, we have many different astronomical events happening in the sky. You might have so you might know about the Milky Way, and then you might have heard about some nebulae. For example, this one is called Heart and Soul Nebula because this kind of looks like heart, and this one, yeah, it's called Soul because it's with heart. And then you might have seen some eclipses For example, this is a photo of lunar eclipse, total lunar eclipse. And also the most spectacular eclipse is the total solar eclipse, wherein you can see the corona of the sun, and then you can also see some prominences around the sun. And also sometimes you see things like meteor showers. So in one night you see many meteors in the night.
Hello, sir.
Hello. Yes.
Sir, actually, your screen wasn't shifting. Now we can see.
Okay, so I'll just so if I change the screen, I'll just give you a few seconds and then I'm down. So now you can see the photo of the meteor showers, right? So this was
Yes, sir.
captured in I think in December 2011 during the Gemini meteor shower. So the constellation of Gemini is over here, and we can see that all these different meteors, they seem to be originating or going away from the constellation of Gemini. So that's why they are called Gemini. So, there are all these different types of photographs that you can take, and they can be termed as astro photographs. So why do we need to do any processing? So some people say that any processing that you do, you're actually changing something. So if you see a photograph and somebody tells you that, yeah, I used Photoshop to process it, then people will say, oh, Photoshop. So that means people have this notion that anything that you process using Photoshop or any other astronomical software or any image processing software, it is not really pure. But then our cameras are not really built to do astrophotography. They are optimized to do daytime photography and normal photography. Right? So the astrophotography is slightly different. So we are dealing with something that is very faint and very far. So the camera is not really optimized to take photos and also visually depict them in a very beautiful way. One thing that you should note is any camera does processing within the camera itself. So whatever output that you see on the camera screen, sometimes you may see that, okay, I click a photo, let's say you're taking a photo with your mobile, and then you see that the colors that you really see with your own eyes and the color that you see on the screen, they will be somewhat different. So when you're taking a shot of the sunset or anything for that matter, the color reproduction may be different in a camera than what you see through your own eyes. So camera actually does some processing inside. And also it also depends on the screen on which you are seeing. So if you see the same image on a monitor and then on a mobile and then and on a, let's say for example, a CRT monitor or a TV, so and also a print, so all these will show different colors, not exactly the same colors. So so basically all these devices, electronic devices and printers, everything is actually doing some kind of processing before outputting something to see through our eyes. And what we are trying to do in image processing is to make the image look beautiful. But we are not trying to add anything extra to the image. We are not adding stars to the image, or we are not really trying to add some colors that are not there in the image. What we are trying to do is to enhance what the data that is already present in the image. So, for example, let's say, for example, this is the image that is directly from the camera. Okay, so you can see that there is this faint Milky Way which is visible all as a band in this one. But it's not really looking nice. Somehow we have to process it and make it look nice, and that's what we will try to do. And then another thing that to note is sometimes you see some images that may that are called false color images. For example, many of the Hubble images, say for example this one, it's called the Pillars of Creation. You can see it here. It's called the Pillars of Creation, and this is a false color image. What is the meaning of false color image? So the Hubble telescope has many different filters to capture the images. So you put a filter, you take a photo. You put another filter, you take a photo. And then all these filters, some of these filters are in the infrared range, and also I think also in ultraviolet range, which we cannot even see with our eyes. So whatever you cannot see with your own eyes, how do you give a color to it? So artificially, a particular color is applied, and then the image is produced. So here, the colors that you see, they are actually artificial colors. So if you take a telescope, point at this Eagle Nebula, and then if you see this, you will definitely not see these colors. But what does this do? This actually helps us to understand the structure and understand the physics visually by looking at this image. So you can see that there are all these pillar-like structures made of gas and hot hydrogen, wherein new stars are being born. And this image, although it's a false color image, it actually depicts that concept. So these are false color images, but what we will do today is only true color processing. In the sense, the color that is already there in the image, we will try to enhance it and make it look beautiful. Okay, so maybe this was how we got it when we captured the image through a camera, and after processing, it may look like this. We don't know. Let's try and see what we get. Okay, so we will practically go through each step that is involved and try to get to this kind of picture. Okay. Another thing. Okay, so first example that I wanted to show you was a star trail. Okay, so what is a star trail? Okay, so this is a star trail. Okay, so what is the meaning of star trail? So you can see all these trails, all these lines, they are actually stars. Okay, the stars are actually moving in the sky. So as you know that the sun moves from east to west, all these stars also move from east to west. And here, this photo actually it tries to capture the motion of the stars in the sky. So if you keep the camera on, if you keep the camera on for let's say 60 minutes and try to capture all the light that is coming from the star, and the stars are moving in the skies, you will actually see this kind of trails. But the problem is, if you keep the camera on for 60 minutes, because of the ambient brightness, okay, somebody is saying they can't see anything, but can somebody confirm whether that's the case with everyone or only that person?
So it's visible.
No, sir, it's visible.
Okay, it's visible. Okay, all right. So probably some of you might have some internet connection problem or bandwidth issue. So yeah, please bear with us. Okay, so what we are trying to do is so as I was telling you, if you keep the camera on for 60 minutes and if you take a continuous shot for 60 minutes, because of the ambient brightness, the camera sensor will actually get saturated and you will just get a white image. So how do you capture the motion of the stars in the sky? What we will do is we will actually capture multiple images of shorter exposures and then try to combine them. Okay, so and that's what I will show you. So yeah, so this is a sequence of images, and I'll play the sequence one by one. So this was the first image. This was the first image, and then you can see that the stars are actually moving in the sky. Okay, so this was during the night. This was about, I think, probably around 2 a.m. or something like that in the month of May. So the light that you see around, that is from the moon, which was behind me. So I was pointing my camera towards east, and the moon was setting in the west. So you can actually see that the shadows are actually growing. And the sky, which was actually much brighter, it's becoming darker and darker. So, yeah, this light that you see at the right bottom, that was somebody who was using this torch and coming out of the tent. And now you can see that the moon is setting behind me, and you can see the moon has become red, and that's why you can see the red color on the red reflection on the mountain also. And you can see that you can see a faint, you can see Milky Way somewhere around here. And that's it. So this was my exposure. So I took continuous shots of the mountain and the stars. And let's try to see how to combine this. Okay. So to combine this, we can either use Photoshop, or we can use software called Star Trails. Okay, so the name of the software itself is Star Trails. So to get this software, you have to go to a website, startrails.de. I think it's a German website, so it has startrails.de. And if you go there and download it, it's very easy to use. So once you have taken these images, you have to open those images. Let's take, let's say, okay, come here. Okay, so I have all the images loaded here. And then I can actually create the foreground. So this is my foreground. And then I can create Star Trail. So it has two options. Either you can do a faster process, or you can do make sure that there are no gaps, but it's a slower process. So for this, for the constraint of the time, let me just click this and click OK. And you can see the trails being formed. So basically what this is doing is kind of adding all these images together. And when it adds all these images together, you start getting trails. So the question is this photo fake? Will you go to this place, and if you go to this place and if you see, will you see these lines in the sky? Of course you will not. But what is it doing? It is actually representing the a phenomenon in the sky, which is a very beautiful phenomenon in the sky. So now you can see that all these lines are stitched together, and you can see all the lights of people moving around from the tent also visible here, and the whole scene looks like it's daylight. So to make it look natural, we can probably do some more processing in let's say Photoshop, and then try to decrease the brightness of this and so on, so that it looks more natural. Okay? And the concept that we are actually seeing here is the rotation of the stars. And you can, if you observe very carefully, if you see this particular line, it's almost a straight line. Okay, so there is some star which is kind of rising in the east, and it's going towards west. And this is exactly the east direction, right? And then all the stars which are towards the north of this one, they are arcing upwards. So they are all arcing towards the North Pole star. And everything that is below, they are actually arcing towards the South Pole, or South Celestial Pole. So basically, it is also a representative of Earth's rotation, right? So you can see that some stars which are in the north are rotating. I mean, are making smaller arcs compared to some arcs which are exactly in the east. Similarly, I just want to show you another one, which is probably more familiar, which is more familiar to you. Okay, I have a lot of images. Probably I'll just choose 30 images for this example. Okay, so this image is of a telescope. This is a gamma ray telescope in a place called Hanle in Ladakh, and this is one of the biggest gamma ray telescopes in the world. And this is being built by our own Indian scientists. And this is actually pointing to the pole star. So you can see here, you can see here there is a star which is not moving at all, and this is actually the Polaris, or the pole star. And you can see that as we go away and away from the pole star, you can see that all the stars are making arcs, right? So I have added 30 such exposures. Now let's construct the star trails. So what you need to know about this is that if you point your camera towards north direction, and then take multiple photos and add them together, you will get this kind of concentric trails. If you point to the east, you will get straight lines, but those are also in a way very interesting. All right. So this is another star trails image in front of Mace telescope, Mace gamma ray telescope in Hanle, with all these concentric circles, which represent the rotation of the Earth. And you can see that so the center of all these circles, that's the exact North Pole, and the Earth is actually, so it points to the rotation axis of the Earth. Okay. All right. Any questions so far? Okay, so if there are no questions, then probably we can move on to the next example. So So here, through this software, we can only see visible patterns. What do you mean by that? Visible patterns? Okay, so maybe we can take questions later, and for now, continue to see some more examples. Now, this image, it's so you can see the details of the image here. Actually, it was taken on 2016, April 17th at around 4 a.m., 4:12 a.m. 12th in this sequence. So I was taking a sequence of images. So this was the 12th in the sequence. And it has ISO 1600 and 300 seconds of exposure. So actually in your camera, you just get maximum of 30 seconds exposure. So you need to use either a software. Can't we make trails of radiations from this software? Okay, I don't understand your question, so maybe we can take up the questions later. Yeah, coming back to this image. So your camera is just capable of taking 30-second images. So if you want to do longer exposures, like 300 seconds, then what you need to do is you need to have an intervalometer and set the time in the intervalometer and do bulb exposure. So you just open the shutter for a very long time for 300 seconds and then close using your intervalometer. So that is the hardware way of doing this. Another way of doing this is with software. So there are many softwares. So there is one tool called Astral Photography tool. And then there is another one called Backyard EOS. There are multiple such softwares. And with these softwares, you can you can connect the USB cable to your camera, assuming that it's a DSLR camera. So you can connect the USB to your laptop. And in the laptop, you can actually specify how many photos have to be taken, what should be the settings of each photo, and so on. So this is one such photo taken with Canon 6D camera with 300 seconds exposure at ISO 1600 and so on. So so when you open this, actually you need to also install a plugin called Camera Raw. So if you have a Photoshop subscription, then Camera Raw actually comes for free. You can just download it from Adobe website and you can start using. Could you please explain the ISO? Okay. ISO is actually it's got to do with sensitivity. Okay, so if you want to make your sensor more sensitive to light, you have to use higher ISO. If you want it to be less sensitive to light, then use lower ISO. So let's say, for example, if you are taking photos in bright daylight, then you don't need your camera to be very sensitive to light. So it's like, for example, if you consider our own eyes, when we are in broad daylight, actually our eyes are kind of less sensitive. No, actually that is not a good example because it's the aperture that is changing, not the ISO of the eye that is changing. Let's just take it this way. So the sensitivity of the camera can be controlled, and this sensitivity setting is ISO. It is related to the management of sensitivity of light. Correct. So this ISO term comes from actually film. So during the film technology, you had film that was less sensitive, which was cheaper, and film that was more sensitive, that was costlier. So you would get ISO 100, ISO 200, and ISO 400 film. So now in our camera, to mimic that, we have different sensitivity settings. So during broad daylight, you would probably use ISO 100 or 200, and in the night, probably you would use ISO 1600 or 3200. Now, what happens is if your camera is if you make it more sensitive, that means if you increase the ISO, the noise increases with that. So you get a very grainy picture if you take photos with higher ISO. But if you try to do with the lower ISO itself, what will happen is you will need more exposure time. So the sensor has to collect more light. So it has to expose for more time. And if you're taking photos of moving objects, the objects would have moved by that time. So you would get a very shaky image. Or if you are taking photos with handheld camera, then your hand may shake, and so the photo will be very shaky. So it is a compromise between having a higher sensitivity and more noise, or having lower sensitivity and increasing the exposure time. So I would say that the thumb rule is basically if you have more light, if you have very good light like daylight, then use very low ISO. But in the night, if you're taking nightscapes or something like that, use a higher ISO. And also for astro, it's a totally different ball game. So you have to use tripod, otherwise you can't take good photos. This particular photo was actually taken with a tripod as well as a tracking mount, because as I showed you in the previous picture, in the previous picture I had just put the camera on the tripod directly. So you can see that the stars were trailing, the stars were moving in the sky. But in this one, you can see that the stars are actually pinpoint. They have not moved. In 300 seconds, the stars have not trailed at all. That is because I was using a tracking mount, which tracks the stars, and then it keeps the stars as pinpoints instead of making them trail. So it is like the stars were moving, and my camera was also turning in that same direction as that of stars. So after 300 seconds, so I think that's a little bit, that makes it a little bit clear about the ISOs. So you have got this image, and now you have to process it. So the first thing that we need to look at is the histogram, this image that is here. So what is the meaning of this? So the meaning is you can see an axis, you can see an x-axis over here, and a y-axis which is over here. Just imagine a y-axis over here. So the x-axis actually represents the brightness, and the y-axis represents the number of pixels. So here you can see that at low brightness, at less brightness, there are no pixels, and at very high brightness also there are no pixels, and all the pixels are in this mid-range, or they have kind of brightness which is around this region, right? So what happens in this case is that there are no dark pixels, there are no very bright pixels. All the pixels have almost the same brightness. So the meaning of this is that there is no contrast. So all of them kind of look like same color, same brightness. So we cannot really make out the structures that are there in it. So what we need is more contrast. So one way to increase contrast is by doing this. But so it's slightly effective. I'm able to see some more details than before, but not very effective. So let me not try that. What else can be done is we can go to this curve, and in this curve we can try to actually, so you can see that there is a lot of background brightness, right? So I can try to reduce this background brightness. So this is called a black point, and this is called a white point. Okay, so black point I am setting over here. What this means, you can see in this one. So what I'm trying to do is I'm trying to push this histogram towards left, which means now I have some dark pixels, and then you can see that actually there is some change in this picture. Now I am actually kind of seeing some more details than before. So here this looks very dull, and now as I change this, it's actually bringing out some details. But before doing this, I need to do one more thing that I forgot. Sorry for that. So what I need to do is the camera raw actually comes with some built-in optics correction. So what is the meaning of that? So if you see here, you can see that the corners actually they are very dim, right? So all the four corners they are dim, and the center is brighter. That is because of the property of the lens. The lens that I had used was a 24 105 mm lens at 24 mm with aperture f4, and with that what happens is the illumination is not uniform. The center is always brighter than the edges. So the Photoshop software, the camera raw software actually has some corrections for that. So there is something called as a profile correction. So it will, based on the properties of the lens, it will try to correct for distortion and vignetting. So the vignetting is actually that thing where the edges were actually less brighter than the center. Okay. So now, if I unclick this, you can see that edges are actually dimmer, and when I click this back, you can see that it's kind of corrected. So if you see that there is still some minor adjustment to be done, those minor adjustments can be achieved here. Okay. So if you want to make the effect less or more, you can adjust it here. All right. So there is also another option to remove the chromatic aberration. Chromatic aberration is when you see some purple fringes around the stars and so on. So maybe we can just click that and to remove that. And then now we go to curves, and then now we try to reduce the background. Okay. So already the image is much better, right? So we can go to the basic, and we can also now try to, let's say, increase the contrast. Contrast is not really working out for me. So I can actually try to do some more thing. So like increase contrast using this slider, the curve slider. Go back to basic, and then I can try to play with these highlight, shadows, whites, and blacks. So blacks are actually the darkest pixels of this one. So all these things that I'm showing you, you can actually do with mobile apps also. So there is a Photoshop mobile app which is free, and whatever I'm showing you, you can also do with the same mobile app. So blacks. So blacks are the darkest pixels in the So if you want to make the darkest pixels dark, whites are the brightest pixels. So like stars, and then you have control over shadows, which are somewhere in between the brightest and darkest, but closer to darker pixels. And then you have highlights. So you can adjust all these things in a way that this becomes more beautiful. Then there is a feature called dehaze. So if you see some kind of haze in the image, this dehaze will try to remove that haze. Yeah, so it can make it less hazy, but I have already made it less hazy, so it doesn't work really well. Then then the question is of color. So we see, okay, there are some yellowish colors, pinkish colors, and so on. Now, if we want to make these colors pop up, that can be done with vibrance and saturation. So let me just increase the saturation a little bit. So now you can see very nice colors. Also, you can try to increase the vibrance, but vibrance is not doing me any good right now. And saturation increase is also very high. So let me just dial it down. We around 30. This looks good. So now what has happened is, because of all this editing that I have done, if I see there is a lot of noise, there is a lot of graininess in the image. So to take care of the graininess, I can go to detail, and here I have noise reduction and color noise reduction. So noise reduction, this is actually kind of luminance noise reduction. So what this will does is it will try to remove this noise, the graininess in the image. But while doing that, it also actually makes the image very soft. So let me just make this 100. And now you can see that the image has become very, very soft. So we have lost a lot of detail. So we don't want to do that. So I would say, according to at least for my camera and my processing, I would say 25 or less should be good enough. You have all your so let me just make it 0. You can see there is a lot of, I don't know whether you will be able to see this in the live screen or not. This will need, you need to be in front of the monitor to actually see this. And then you can actually set it to, let's say, 25, and you can see that some of the noise has disappeared. And the color noise, actually, you can increase it up to 60 or something. So now the image looks more cleaner. Okay? So if I take it back, so you can see that the image actually looks more clear. Okay. There is one more thing that we can do. So I mean, let me show you one more thing. So once you are done with processing with Adobe Camera, you can actually take it to the Photoshop. So this is what we edited and got from Photoshop. So now in Photoshop also you can do many things. One of the things that I would like to do is, I don't like this greenish color. This greenish color, it could be because of the air glow that was there during that time. So you can probably read more about air glow on Google. So basically, it kind of produces a greenish in the sky. It's not aurora, that's different, but this is air glow. And then what I like to do is, there is a guy named Rogelio Bernal Andrio. He's one of the best astrophotographers in the world. So if you want to follow astrophotographers, please do follow Rogelio Bernal Andrio, and he is probably, he's one of the best astrophotographers in the world. And he has created a plugin called HLVG. It's free. So HLVG means Hasta la Vista Green, which means it will just take away all the green in your. There are 3 different settings, but let's just keep it at strong setting and see what happens. So observe this greenish thing and what happens to it. Wait a second. There is some issue. Somehow this isn't working. But why? Let's try once again. Okay, for some reason this isn't working, but basically this image should have kind of become like this with all green light removed. So don't know why this is not working. But just for now, just believe me that it will just remove all the screen and will make it look like this. And then one more thing that we can do about this image is that you can see that here, so there was light pollution in this area. So you can see that the right bottom portion has more light compared to the left top. So we can try to kind of utilize that. And how we do that? It's by using the camera raw filter. So the camera raw filter, it can either be used in the beginning when you open the image, or it can also be used later. Once, I mean, in between, if you need to do something. So here there is something called as graduated filter. So I can apply this graduated filter, and you can see the graduated filter. So what this says is that any effect that I want to apply, it will be applied to this whole area below the green region. It will not be applied to any area over the red region, and it will have a gradient from here to here. So let's say, for example, so if I increase the exposure, for example, you can see that the increase of exposure has been applied completely to this area. In this particular area, it has been kind of partially applied. Or here we have more, and it's become less and less and less, and here it becomes 0%. And anything above this, it's completely 0%. So I can actually do something like this also. So you can see that gradient. So what I wanted to do with this is actually not to screw up my image, but what I wanted to do is, let's say, for example, this area is more brighter compared to this one. So I can probably try to decrease the brightness of this area. Okay. That can be done. So, and then also I can probably apply one more time the camera raw filter, but on the opposite side. So I can probably have another one here, and maybe increase the exposure on this side little. So, okay. Yeah. So maybe like this. And maybe try to increase the exposure on this little. Okay. So and again, if I want some more contrast, I can also probably bring in some more contrast. And if I want, I can increase the saturation a little bit more. So all these can be done in multiple steps. Another thing that can be done is we can go to hue saturation, and we can do greens, and we can actually decrease the saturation of the greens. Yeah. So you can see that the green screens have been reduced. Yeah. So all these kinds of different things can be done to actually make your picture pretty. Let me try to apply this HLVG just one more time. I can actually show that HLVG effect in another software. There is some problem with the software that I'm using for some reason. I don't know. So let's just save this. Okay. Okay. So I can open this in my favorite astrophotography software, which is PixInsight. And then I can actually, what I can do is, I think I want to increase the brightness a little more. And I'll apply something called as, this is actually equivalent to doing Astral green. Okay, so yeah, looks like it's not doing bad side. But anyway, okay. So finally, you can slightly increase the color a bit. Sorry, increase the brightness a bit, and then you're done. So you have a nice photo that you can publish. So all these techniques that I showed can be applied from your mobile also. And using the either Snapseed or the Photoshop app. So all these are applicable to different platforms. One more thing that I wanted to show is actually, let's see. The Andromeda Galaxy. So let's start from the beginning. This is the image of the Andromeda Galaxy. So you can't see much. This software is called PixInsight, and PixInsight is probably the best astro software out there, and it has a lot of very nice features that are useful for astro photography. So one thing you might have yesterday probably. Ajay Talwar might have shown you explained you some things. So if you are taking photos of the night sky, you need to do certain things. So you need to take multiple types of images. So those are called bias frames, dark frames, flat frames, and light frames. Did Ajay Talwar talk about this? Somebody from the organization team, can you tell me?
He told about stacking, sir, but he did not inform about the frames.
Sorry?
He did spoke about stacking process, sir, but the frames are not mentioned in detail.
Okay. All right. So basically, you have to take multiple different types of images and then combine them together to get your final image. Okay. So for this image also, I have taken some 50-60 images, combined them together, and this is the output image. Okay. So in fixing side, so what we try to do is like this. So first of all, whenever I see any image, in the previous image also, I showed you that there was a gradient in the image, right? So it was very difficult to remove the gradient in the image using Photoshop. So we tried to kind of manage it, but still you can see that this area is darker, this area is brighter. In my previous trial also, I got something like this, but still this area is darker and this area is brighter, and it's not well balanced. So in inside, you have many processes available which automatically try to remove these things. So let's say, for example, so um, this this process called automatic background extractor is actually tries to remove the background and only keep the object in focus. And also there is one more process called dynamic background extraction, which does the same thing, but you have to do it manually. So any kind of gradient can be carefully removed by using these processes. And then one more thing I would like to do is kind of just crop this image a little bit because it is not well framed. So you can see that there is this galaxy is in the left side and there is nothing on the right side. So maybe I should have framed it better. So just give me a second. Okay. So I crop this image, and then what I do is that I apply I apply the kind of stretching of the image that I did. So now you can already see a lot of details in this one. But you can also see that the core is actually kind of overexposed. So if I want to bring back the transform, and I will just show you the result. So now you can see that it has tried to tried to bring back the details. So the core, which was very bright, so now the core brightness has decreased, but the other places have remained the same. So you can now see more details. Right? There is also another thing that we had to do. So that is called color calibration. So what happens is, if I see the histogram of this one, sometimes the histogram may be, let's say, for example, in this one it is okay, but what can what can happen is maybe the histogram may look like this. So you may see that the blue and then red and green channels, RGB channels, may not be aligned together. So then the image will have some kind of a color, what do you call, color bias, or it may be biased towards one particular color, right? So many times you may see that this is biased towards red or something. In that case, we can actually apply something called as color calibration. For this one, it is not really required. So what I'll do is I'll show you one more thing. So this is again the same saturation that we applied in Photoshop also. So here you can see some more colors. So it's basically enhancing the colors that are already there in the image. So now this one looks too much. So I can dial back maybe. And then I can also apply that multi-scale HDR multi-scale transform to make the core a little bit less bright. Yeah, so now you can see more details around the core. And then I can also probably use SCNR. Yeah, so now this looks more natural, and you can see more details in the image. So the PixInsight software actually in photo many things very quickly, and also it has very what you call very powerful tools. Like for example, what I'm trying to say is, if you take this just histogram transformation, right? This is a basic tool called levels in Photoshop. So in this one, you can actually do a lot of things. You can actually zoom in into the curve and do precise changes, like very small changes can be done. So and then you can either upload the alpha channel and then RGB and so on. So there are many things that you can do. You have so you can either add this line, so all these different things, and then you can remove the grid. So you have all these different options that can be used to modify things in PixInsight. And it has also got like in the curves, not just the brightness, but in the curves you have also got the saturation option apart from just RGB. So you can see the preview. So this will just brighten the image or make it darker. So let's say, for example, I like it like this. And then if I want to just increase the saturation, I can just increase the saturation. So now it looks much better. So let's apply. So maybe another ground can be applied. Yes, something like that. So you can do a lot of things in PixInsight also has a complete stacking platform. So you have this. So you can add all your light frames, flat frames, dark frames, bias frames, do the stacking here, and then see the output. So yeah, this is PixInsight. I really like PixInsight. So many of my images are actually processed in PixInsight. So let's say, for example, this is the Orion Nebula. So this is a very old image. It's not a very good image. So this is an image of Milky Way. So again, this was by stacking multiple images, and then yeah, this is also okay, not a bad image. So this is Orion Nebula and Running Man Nebula together. And yeah, this is Milky Way with some tents and mountains below. Yeah, so I have some more. That's it. So these are some of the things that I wanted to show you, like what you can do and the basic settings that you can do to process the images. So probably if you have any questions, we can take those questions. Can you provide us the link for PixInsight? It's pixinsight.com. This is a paid software, but you get a 45-day trial, so you can use that. Okay. Are there any questions? Sir, can you explain about master frames? Okay, so maybe I can do that. Yes, I should have power. So maybe I'll just take some 10 minutes. So what we are trying to do is can be explained simply like this, right? So whenever you have an image, because of the properties of the sensor and because of the quantum nature of the light, we have noise. So this is ideally what you want to get, but this is what you're getting directly from the camera. It is very, very noisy, but this noise is random. So if the noise is in one pixel in this image, in the next image, it will be in a different pixel. So the noise kind of keeps moving around. So what can we do? So we can actually try to combine multiple images. And when we combine multiple images, this random noise gets averaged out, and you will start seeing the decrease in noise. So let's say this is one image, and when you stack about 32 images, this is how it would look. When you stack about 128 images, it would look like this. When you stack about 1024 images, it would look like this. So you just average, you just take hundreds of images and then average them together, and then you will see that the noise would have reduced. Okay, so that means, should I take thousands of images? To take thousands of images, I need to work for years. So we don't want to do that. So so if you see this curve, the SNR actually, so basically the noise reduces as you increase the number of images, but the noise reduction is very, very steep over here. But after some time, you don't really get much benefit. When you go from, let's say, first 20 images, like when you have 20 images, you have about 75, about 85% of the 85 to 90% of the noise removed already. And when you have 200 images, from, let's say, 90% to 95%. Okay, so it's not very useful. So I would say, as a thumb rule, about 40 images is good enough. So you take about 40 images, and then you reduce the noise by, let's say, about 92%. And the rest of the noise can be reduced later when we do post-processing, like the noise reduction that I showed you in Photoshop. And nowadays there are some softwares like this Topaz denoise AI, which actually use artificial intelligence to reduce the noise, so they are much more effective. I really like this denoise AI, but this is also a paid software. So yeah, but anyway, so basically we want to take multiple images, then do the stacking and reduce the noise, and then the leftover noise can be reduced during post processing. So for this we take different types of frames. So light frame is where you are actually taking an image of something that is there in the sky. So here in this case this is a comet. So you can see the head of the comet, the nucleus of the comet, but you can see a lot of artifacts. What do I mean by artifacts? So you can see that the edges are black, and then you can see all these dust motes. You can see all these circles which are due to the dust either on the sensor or on the lens, probably on the sensor itself. So now how do I remove it? How do I get rid of this? So the technique that we use is using a flat frame. So what is a flat frame? Basically, instead of pointing at the sky, you just point your camera at some uniform light source. Okay, some let's say a flat LED panel, or maybe the monitor of your PC with just white screen. Okay, so it should be uniform. So now what I'm getting is I'm getting the profile of the illumination of the lens, and I'm getting all these dust motes, right? So here you can see the dust motes, and the same dust motes can be seen in this image also. Now the idea is if I take this image and divide by this image, everything should get evened out. So when I take this image and then divide by this one, it will actually just even out the whole image, and the whole image will be of same brightness, and I will get rid of all these dust motes. In your camera, you might, if you have a DSLR camera, you have an option called dust delete data. So that also does the same thing. It says you point at a white wall or a white monitor or something. Camera can internally do this. But then when you're capturing the images, it takes time to process and then produce this image. Instead of that, you can continuously take light frames and then take a flat frame and then let the software handle it. And then there are dark frames. Okay, so basically, if you just close the lens and not allow any light to enter the sensor, your sensor should have absolutely black image as output, but it will not be completely black. If you just stretch it, if you just apply this histogram transformation or like curves or something, and if you see, you will see that there is already some noise. So this is due to, like, if there are some electronics students, so this is due to the dark current of the sensor. So your sensor has transistors. The transistors have this leakage current because of pressure, and that causes this noise. Now, this noise can be reduced if you just cool the camera. So if you cool the camera to really low temperature, you can actually reduce this noise. But we also have some software techniques to do this. So what we will do is we will first take the light frames, and then we'll close the camera, and we will take some photos with the closed camera. So then I get this, and then I can just subtract this from the light frame. So I have the light frame, I just subtract this. So all this noise that I have got can be removed. Okay? And then by applying all this division, all this subtraction and other things, I get, and also after doing the stacking of multiple images, what I get is this. So here in one image, you can see how bad it looks. And then after processing, This is the image that I get. Now, this image also has some noise, but that noise can be removed in the later process. But you can see that all these dust modes that we had, and this illumination, and also a lot of background noise, that has been reduced a lot. The signal to noise ratio has been increased. Here you can see just the, let's say, the nucleus of the comet, but once, and then you cannot see any tail, but once we combine multiple images, we can see some portion of the tail, and we can see the extension of this nucleus, and we can see the color of the nucleus being green. So this is the advantage of stacking. Now, again, this has to be processed to remove all this noise, to make it look much more beautiful. But basically here I'm just showing you the output of the stacking. And after the stacking, like whatever I showed you, all this processing for the Andromeda Galaxy, the same thing can be applied to the comet also, and we can make it look beautiful. So that's the gist of what stacking is. Telegram group link. Yes, I can provide you the Telegram link. So here is the link. So you can fill this Google form, and you will get the link for joining the Telegram. Okay. Are there any other questions? Sir, which camera do you use, and what lenses do you use usually? So I have a Canon 6D full frame camera, and the lenses I have are, this is my most favorite lens. This is yeah, probably it's a 200 f2.8 lens. So let me just stop sharing so that you can see my camera. So yeah, so I have a 200 f2.8 lens. This is one of my favorite lenses. Then I have 50 f1.8 lens, and then I have a 24 105 lens. Yeah, these are the lenses that I usually use. I have a Nikon 50 f1.4 lens, which I use extensively. So 50 f1.4, 200 f2.8, 24 105 f4. These are the lenses that I mostly use. I also have a telescope. I have a 8-inch f4 telescope. Okay, f1.4, f2.8, and other f's. Like I usually have doubt in that. Let me see. All right. So basically, it has to do with the aperture, right? So aperture is actually the what do you call it? The diameter of the lens that you have. So if you have lesser diameter, then you have a higher f number. If you have a bigger diameter, then you have lesser f number. So f number is actually aperture divided by focal length. Okay, so let's say the aperture is 50 mm, and let's say the focal length is 100 mm. Then it's a f2 length, right? So 100 divided by 50 is equal to 2. So it's an f2 lens. So now in the lens you can set the aperture. That means you can actually you have a diaphragm which can decrease in size and make it smaller and smaller. So when you have f16, you'll have a very small opening. When you have f2.8, you will have a bigger opening. So that will be on this side of the lens. So you'll have a diaphragm, and so it can actually close and open. So based on that, you can change the diaphragm. Okay, so free software. So basically for stacking, so you have to use Deep Sky. You can use a Deep Sky Stacker. This is a free software. And then also there is something called a Sequator, which I have not used, but many people have been using it. So this is also very nice software. And then there is a software called Images Plus. It was a paid software before, but now it is free. So Images Plus is a very strong, very powerful software. It was a main competitor for PixInsight, but now the developer of Images Plus, he has stopped developing, so he has made that software free for everyone. So you can download images. You can try Images Plus. Then what else? Yeah, there is GIMP, which can be used as a substitute for Photoshop, but yeah, it is not as powerful as Photoshop. I have never used it, but it's an open source software, and it seems it's very nice. So you can try that. What else? Yeah, these are the free software that I know of. So if you for capturing, you have Astral Photography tool. So you can actually download this. So basically, you can automate capturing the images in a sequence. Then what else? What about MATLAB for image processing? Yeah, MATLAB can also be used for image processing. So there are a lot of algorithms. Like for example, if you see here, you can see some algorithm names. Like you have wavelet transforms that can be used. To actually just sharpen the images of particular wavelet layers and so on. And also, yeah, you can see multi-scale linear transform and all that. So PixInsight actually has implementation of many different algorithms like ACDNR. There is also an algorithm to decrease noise. There's TGV noise. So all these algorithms, it has really good implementations of those algorithms. So you can actually look at which algorithm is applicable, and then you can try to implement that in MATLAB. But MATLAB is also a paid software, right? So you could probably invest in PixInsight if you're planning to invest on MATLAB. So there was IP for AP. There was a book on how to not this one. I forgot. There was a book on how to do image processing, astro image processing in MATLAB. Probably, if I remember, I'll send it to Sai Shankar, and probably he can forward it to you.
Sure, sir.
Okay, so if there are no more questions, then probably we can end the session. And I thank you all for attending this session. I hope it was a little bit useful, and let us know your feedback. Thank you. So, organizers, can I close the session? Leave this? Can I leave the session?
Thank you, sir. I, on behalf of SEDSKCT, the entire crew behind the event, and myself, want to extend a hearty vote of thanks to the speaker, Mr. Keerthi Kiran, and all the audience who graced the event in great numbers. A big thank you to the speaker for an amazing and insightful speech on the colorful cosmos processing astronomical images. We all are grateful to hear from you, sir. Thanks for spending this great evening with us and have a great day. Thank you all.
Thank you. Bye.